Alright everyone, this is the next page. This is Denise has a prepaid cell phone. This is going to be a two-step equation from a word problem. And here, this will just take a few minutes. This is just what the definition of a straight angle is. So let's do problem 15. Denise has a prepaid cell phone. This month, she would like to spend $9 on a cell phone plan. The cell phone charges 10 cents per minute of call time. What is the maximum amount of minutes that Denise can purchase to stay under 45? So for this, we don't want anything greater than 45. I'm actually going to model something else, so a different type of problem. Let's say Denise would like to spend this month, she'd like to spend $9 on a plan. It doesn't even quite make sense. This month she would like to spend this, but she would stay under $45. This is a little bit confusing. This is what this problem means. She spent $9 on the call plan, and so that's our starting charge, and then there's 10 cents per minute. And she would like to spend under 45. Confusing problem. My apologies for once again, another error on this IA. I can't begin to tell you the frustration that I've had. Okay, so let's say Denise on a different plan. So let's say this was AT&T. Let's say that she wanted to buy Sprint. The Sprint's plan is $15 initial charge. So notice I'm using the same colors here, or slightly. I think they're the same, yep. $15. And then the company charges $0.12, so 12 cents per minute. So this is initial fee or charge, and this is per minute. Let's say I don't want to spend, I'm sorry, I know I'm kind of doing the math in my head. This is my 7th video, so bear with me if I'll do I'll do 75. Okay, so let's say that we don't want to have, and then we want to stay under, $75. We don't want to spend anything more than $75. So I know I start with this, it's this per minute, and for this week I want to stay under this. So the equation from this is going to be 15 plus 0.12 minutes is equal to 75. Okay. Now notice here, it's giving me in hours. And one of you, Alondra, pointed out, Horus, another error. Horus is the ancient Egyptian god of wisdom and vision and knowledge. So they're saying 10 Horus Egyptian gods. So you knew that that one couldn't be the answer because there's nothing about ancient Egyptian mythology in the problem. Okay, enough with crummy jokes. Okay, so we've got this equation here. All we need to do now is solve for minutes. But, sorry, the answer choices are in hours. So make sure once you solve for the minutes, you got to convert it to hours. Okay, so we'll subtract. We're going to take care of the addition or subtraction first. The 15 is being, you can read it both ways. The 15 really is being added to this 0.12 times m. we'll take care of this one first. If you wanted to, we could have also done this. Oops. Write it like this, 15. Either or is fine. I'll actually model both ways. I'm going to subtract 15 from both sides. I'll show you that both answers are going to give me the same answer. Okay, so these cancel, these cancel. Now we've got 0.12m is equal to 60. And same thing over here. We've got 0.12m, that's all we have left, is equal to 60. Okay. Now we're going to divide. Here's the tricky part. I'm going to divide both sides by 0.12. What I do to one side, I must do to the, thank you, the other. I'm just doing it both ways. I guess I can stop. Now, since it's obvious that this is the same as this, I'll just go ahead and do this one right here. Okay. I know that these cancel here, so I'm left with m is equal to 60 divided by 0.12. Okay, now here's the tricky part, dividing this by the decimal here. But let's break it down. What is 60 divided by 12? How many times does 12 go into 60? Well, I know that 1 times 2, 1 times 12 is equal to 12, 2 times 12 is equal to 24, and then I know that 5 times 12 is equal to 60. So 12 goes into 60 5 times. Lots of different colors here. 5 times. These are essentially, they use the same digits. The only difference is the decimal point was moved 2 places over. So let me model one. If I do 60 divided by 1.2, I know that this answer here must be bigger than this 5. The reason why is because the 1.2, it's smaller, so it's going to take more times to go into the 60. 60 divided by 1 is 60, and that's much bigger. So all I need to do, this right here is 5.0. I can also write that. If I moved the decimal point over, I need to move this decimal point in a direction that makes this number here bigger, because I know that this answer must be bigger than this one. Therefore, I'm going to move it this way. So my answer is 50. 50 point. Just erase this right here. Oops. I'll redraw this 5.0. So if I know that's 50, then let's see what 60 divided by 0.12 is. Well, if I moved it, 0.12, I know that I moved it 1 place over, and it's going to be bigger. But I moved it again, and this is even smaller, so it's going to take even more times for this 0.12 to go into the 60. Therefore, this number is going to be even bigger. I'm going to move this decimal point 1 place over, and that gives me 500 point. So, returning